Our final topic in chapter 4 is the switch statement. And the switch statement is a very interesting structure in that it allows for us to structure our program in a way that looks very user-friendly in terms of decision process. So it's used to select among statements of several alternatives, like a menu. I think a menu is one of the best ways to look at a switch statement. In some cases, it can be used instead of an if-else statement. So what I say to you, anything that is programmed as a switch case can be programmed using if-else type statements. But everything that is programmed as an if-else-if type structure does not necessarily code into a switch statement. So switch, yes, everything can be if-else-if, but not necessarily the other way around. So switch is a reserved word, and switch is based on a test expression. This test expression right here must be of integer type. Okay, and when we look at the structure, you'll see that. And then it's based on a series of matching a case. And so case itself, so switch is a keyword, case is a keyword. And so this one has several cases in it, and then a default, always framed by a set of curly braces to show what are the options in the switch itself. Following the expression, again, always a colon, and then what are the statements? Statements always being ended by a semicolon. So I can have several statements throughout. The other word we're going to tuck in here is a break, because without a break, certain things are going to happen in the logic of this switch statement. Switch statements are very common in the newer languages, definitely can be done in Java as well. And so it certainly is a good option to have. So here they use the switch case in sort of a menu type option. Now, if you recall, the case that I'm looking to match with has to be of integer type. So in this case, they use the char. Remember, char in itself has an integer value. So I can use a char or an integer. Okay, I cannot use, so frowny face here, a string or anything that is decimal in type, like a float or a double. That I can't use in my expression down here. So here is my switch. This is what I'm trying to match. So the user entered their choice A, B, or C. Okay, and so I'm trying to match this choice with one of these cases down here. And so let's say the user enters B. So it's looking for a match. This is a matching process. Okay, it's a matching process. So does it match A? No, B does not match A. Does it match B? Yes, it matches B. And so since it matches B, it's going to display you entered B, and then the program breaks. So after it breaks, what it's going to do is it's going to drops out actually to here, drops out of the switch format here. And so let's say the user enters A. If I enter an A, it matches. It's going to drop out of the statement. If it doesn't match an A, doesn't match a B, but matches C, it will print you entered a C, and again, it's going to drop out. Now, let's see what happens. I'm not sure if it will let me change my pen color because some things are in the way here. I'm going to guess not. So let's say it doesn't match A, doesn't match B, doesn't match C. What the default gives us is a final alternative if no match is made. So if no match is made, and in this case, therefore, it's not an A, B, or C, then it's going to say you didn't enter an A, B, or C, and drops out of the switch statement. So the expression must be an integer value or something that evaluates to be an integer. So it could be a test, like a Boolean expression does give me a 0 or 1 as an integer. And expression 1 through expression n must be a constant integer expression or some sort of constant literal, okay, but it still has to evaluate to a number. And it must be unique within the switch statement. And a default is optional but strongly encouraged or recommended. An expression is evaluated. The value of the expression is compared against expression 1 through expression n. And again, it's looking for the match. Okay, and it will continue till it finds one, or it will go to the default value if one is not found. So a break is used to exit the switch statement so that it doesn't go through all of them, and we'll show you what happens. Once it finds a match, it will match them with everything if I don't put a break in. And so a break statement becomes very important to the switch. So let's say in this case here, okay, and this one actually is logically created appropriately. Okay, so the user's asked to enter the model of their TV. And so if it matches with 300, because there's not a break, it will execute, it's got a picture-in-a-picture option. It will also execute stereo sound as an option, and it will also execute that it has a remote control, and then it breaks. Okay, so if they enter 200, it doesn't match 300, but the 200 model will match at 200 saying it has stereo sound, but it also will pick up, it also has a remote control. And then it breaks. So where the 100 model, it won't match 300, so it doesn't have the picture-in-picture option. It doesn't have the stereo sound option, but it has the remote control option, and it will choose that, and it breaks out. So this one, well constructed. Had it been constructed with 100 first, 200, and then 300, then we're going to run into that illogical outcome that the 100 model, which is the low base model TV, in this case here, it would say that it has a remote control, but also would say that it has stereo and sound and picture, but that's not correct. So you have to be careful when you're not using a break, how you construct your switch case statement. So what happens, just like I told you, with the idea that, this is going to, based on model outcome, give you the appropriate accessories that come with that model TV. A switch statement is a natural choice for a menu-driven program, and we will use it in that way. So you want to construct a menu option. Then the user gets to choose off of that one, and then it's going to start looking for a match from the menu through the cases.